Welcome back to part 2 of 3.2. So example 3, consider the equation x squared plus 4y squared equals 4. Sketch a graph of the relation of on the coordinate plane provided. Now, if we were in class, we would pretty much use the TI Nspire, but in this case, we're going to be using Desmos. So make sure you guys go to desmos.com, open up a page, and then enter the equation x squared plus 4y squared equals 4. Now, the nice thing about using Desmos is that pretty much you can type it in exactly as it is. You don't have to do any extra settings. So that's the nice thing about using it, right? So make sure you guys take advantage of using this free calculator. So now that you guys did the graph, you're going to notice that you have x squared plus 4y squared equals 4 is pretty much what we call an ellipse, right? An ellipse. So it has a major and a minor axis pretty much. So this is our ellipse. Now let's make a copy of this graph over here. So we go from here to here. We're from what to what's? And okay, to positive. All right, so that's our ellipse. As best as I could. All right. And now it says find dy dx for the equation above. So again, let's rewrite it. We have x squared plus 2y squared. Actually, 4y squared equals positive 4. So again, we take the derivative, and then we have 2x plus, if you take the derivative of 4y squared, you're going to end up with 4 times 2, which is 8y times dy dx equals the derivative of 4, which is 0. All right. So now we're going to move anything that doesn't have dy dx to the other side. So subtract 2x from both sides. And you have 8y times dy dx equals negative 2x. And then lastly, we're going to divide both sides by 8y to find our dy dx. And we end up with dy dx equals negative x over positive 4y. And then looking at question C, find the slope of the tangent lines to the curve at the points square roots of 2, comma, negative 1 over root 2. So d dx, right? So we want to use a point notation. So dy dx. So our point is a square root of 2, comma, negative 1 over root 2. So that's equal to, we substitute square root of x, square root of 2 for x. So that's going to be negative square root of 2. At the bottom, we're going to have 4 times negative 1 over square root of 2. And that's pretty much going to be equal to negative root 2 times negative root 2 over positive 4. Negative root 2 times negative root 2, you have positive 2 over 4. So your slope is actually positive 1/2. All right. So remember here, I use the keep, change, flip. If you guys are freaking out, what happened right there. And then we want to write the equations of the tangent lines at the points, right? Square root of 2, comma, negative 1 over root 2. So again, using point slope form, y minus y naught equals f prime at a, actually this is f of a, right? Times x minus a. And this is going to be y minus this value, which is our f of a value, which is negative 1 over root 2, equals positive 1/2, which is our prime value at that point, times x minus root 2. So just to clean it up a little bit more, y plus 1 over root 2 equals 1/2 times x minus root 2. And that's pretty much the equation of the tangent line. All right. Now let's look at the last part of the problem, E. Write the equation above explicitly and use the TI graphing calculator, or in this case, the Desmos, right? And then take the derivative explicitly and compare the results with part B. So Let's do that right there. So we're going to solve for x. That's pretty much when it says write this explicitly, right? So solve for x. That will be your first step to write this explicitly. I'm sorry, solve for y. It's not solve for x, solve for y. So here we're going to subtract x squared from both sides. We end up with 4y squared equals 4 minus x squared. And then from there, divide both sides by 4. So you have y squared equals 4 minus x squared over positive 4. And then finally take the square root of both sides. And we end up with y squared, or y equals plus or minus the square root of 4. Remember, you can always do it separately. So square root of 4 is 1 over 2. So over 2, 4 minus x squared. And then we want to take the derivative of this explicitly, right? So let's do that. So let me rewrite this as 4 minus x squared raised to the 1/2 over 2. So we have a constants of 1/2. So now let's take the derivative. So dy dx equals, so 1/2 times the derivative of the outside, which is the root. So that will be negative, actually 1/2 again, right? Times 4 minus x squared raised to the negative 1/2 now. And then that times the derivative of the inside, which is negative 2x. Alrighty, so here again, we're going to pretty much simplify this. We're going to have 1/4 times negative 2x, and then times 4 minus x squared raised to the negative 1/2. So we're left with negative 1 over, actually negative x over 2 times 4 minus x squared raised to the negative 1/2. And then just to finalize it, we're going to end up with negative x over 2 times 4 minus x squared raised to the 1/2. All right, and this technically, because we have a square root, this negative gets absorbed into the plus or minus. So I should have gotten rid of it before. So plus or minus this whole thing. All right, so how can we compare this? So the first one we found was that we had dy dx is equal to negative x over, actually not negative x, it was just, let's look at it over here. Well, yeah, it was negative x over 4y. I did have the negative x. I did have it correctly. Sorry about that. So negative x over 4y. Now, so if we pretty much do that, then we end up with, if you do substitute, remember that y was equal to this ugly looking thing right there. So you would get negative x over 4 times that, which is 4 minus x squared raised to the 1/2 over 2. Simplify that, so you end up with 2 again. So you have negative x over 2 times the square root of 4 minus x squared, which is pretty much what we ended up with when we did it explicitly. All right, now let's look at the last problem. So find the slope of the graph of 3 times x squared plus y squared times raised to the second power equals 100 times x times y at the point 3, 1. Then let's sketch the relation using Desmos, right? So what you want to do here is, again, using the chain. So we have 3 times x squared plus y squared raised to the second power equals 100 times x times y. So we're going to use a chain rule on the left side. We're going to use a product rule on the right side. So here we have 3 times 2 gives us 6. And then x squared plus y squared. And then times the derivative of the inside, which would be 2x plus 2y times dy dx. If you take the derivative of the right side, we end up with 100, right? And then xy, this is going to be 1 dy dx down here. The root of y is just dy dx. Remember that always? Okay, so this would be 100 times x dy dx plus y. All right. And then we want to continue. So we want to solve now. We want to put everything that has a dy dx together. So let's do that. So we're going to have pretty much 6x squared. Should I expand that right there? Should I keep going right there? All right. So I think at this point, just to minimize, because we already know what the two variables are going to be, right? We're just looking for the slope. So instead of just finding everything in terms of x and y, I can just substitute the 3 and the 1 to figure out and then solve for dy dx. That's going to make it a lot easier for us, all right? So let's do that. That's going to be 6, and then, right, so you can have 3 squared plus 1 squared, right? So I'm substituting the x and the y values now, times 2, and then plus 2 dy dx. So you're going to see why it makes this a lot simpler. So that's going to be 3 and positive 1, and then equals 100 times 3 times dy dx plus 1, which was y, right? Okay, we start to simplify now. So that gives us 6 times 9, 10 plus times 6. So that's 6 plus 2 dy dx. And then that's equal to 100, 300 dy dx plus 100. All right, now we collect everything that has a dy dx actually. So yeah, we have 60 here. And then 60 times that gives us 360 plus 120 dy dx equals 300 dy dx plus 100. All right, we're almost done. And then, so we're going to subtract 120 dy dx from both sides. That's going to leave us with 180 dy dx on the right side. And we're going to subtract 100 from that side. So that's going to be minus 100. So that's 260. So we pretty much divide both sides by 180 to wrap this up, right? So we end up with 13 over 9 equals to dy dx.